Hello and welcome to the ninth lecture in third chapter of our comprehensive course on data science, machine learning and artificial intelligence. Now we were doing this thing, object-oriented programming, and I said that these four are the key concepts of object-oriented programming, and we want to understand each concept in proper detail: encapsulation, inheritance, polymorphism, and abstraction. And I want to take one small lecture for these, one small lecture for these, one small for these, like that, so that whenever you want to revise, things are easier for you. Now, before I do this, just a little bit discussion about earlier things which I gave for exercise. For example, earlier we did about this class dog, and I said that this is constructor and all, and then I gave this diagram, and I said that you try to write a class on the basis of this diagram, class car, which has these methods and these attributes. So here I have written, now I am giving the answer, okay, and attributes are two, and they are instance attributes. That means they are not general attributes for the entire class car, but various car objects will have different values for these attributes. So they will be initialized inside the constructor. So def init underscore underscore init underscore underscore, and then self, we always know that self always comes, but then the two attributes will come, max speed and fuel, and then self dot max speed is equal to max speed whatever is passed here, and self dot fuel is equal to fuel whatever is passed here. Then the methods. Now about methods, I told you that don't go into the implementation of methods, just write pass. So this is the first method, def refuel, self, and even this amount also is not required if you don't want to do the implementation. If you want to do the implementation, then you can do that, keep that other argument. Otherwise, I just write pass. Now this is a standard practice by which all programmers do their object-oriented programming, that they first just quickly write all methods with pass, and then they think about what logic they want to implement. For example, here this is the logic which they want to implement inside this method, and therefore that amount attribute was passed. But if no logic is required, then just keep a pass so that there is no error triggered, okay, and you can even avoid passing any argument. Now this is called multi-line comments in Python. That means whenever I execute this code, then these lines will not be executed. Python interpreter will simply ignore these two lines. So if there is a single line comment, then I can put like this. But if multi-line comment is there, then triple single quotes and triple single quotes are used. Okay. Then similarly, the other methods they want us to write is get fuel method. So I have just written that get fuel and self. And again, I don't want to go into the implementation pass. So this is the implementation part if someone insists. The next method is the set speed method. So that set speed, self and speed. Again, if I don't want to write all these implementation details, then in that case even this argument speed is not required, only the self is enough, and you can just write pass. Similarly, get speed, okay, then pass and drive method. All the methods whatever were required were already given in the diagram. So this is how you can implement a class using using the given picture. So most of the time you will have, whenever you are doing object-oriented programming, you have to discuss with the stakeholders that what functionality they want, and they say that I want something like a car, and inside the car there should be these methods and these attributes and etc. He can at the most, if he is a non-technical person, he can at the most show you by this kind of picture or a list kind of thing that I want this many functionalities and this many properties of my car. But then you have to write these methods, and initially just write pass, and then again ask, okay, you have asked me to provide a refuel method. Now what logic you want? In refueling, what do you want to include? So then you can write the logic. Okay. So this is one example, and I can just execute, and no errors were triggered because of that pass statement. Now this was another example. It was even easier. Car class is there, and only 3 attributes are there. Of course, the constructor method will be required. That is this method, def underscore underscore init underscore underscore. Then there are 3 standard arguments, 4 arguments here actually. Self, which is a standard argument, and other 3 arguments you can see from here: color, company, and the model. So color, company, and model. These are instance attributes. They are not common to the entire class car. Every car will have a different color, every car will have a different company, and every car will have a different model. So therefore I have put them here. But if I want all the cars of suppose the same company, then in that case I would put this company attribute here, and then it will become class attribute. I think you understand. That's what we did in that dog example. You can refer to that previous lecture. Okay. Now then there is this method, though here we were not asked to design any method, but I have put one method, display info self. So then it is print self.color, self.company, f string is used, and self.model. Okay. So this is how the class car is defined, and let us see if actually it generates that kind of car or not. So this is class defined. These are objects created. First object created, that is this red car is created. Okay. Then second object created, that is this blue car is created, and then this third object created, that is this the green car is created. And now once they are created, let us see if they are according to what we need them or not. So red, Ford, and Mustang. So that is exactly what we need: red, Ford, and Mustang. Okay. Similarly, the other also you can check with the diagram. So first, it is if you want to do object-oriented programming, then first it always helps to make a sketch or diagram of your class and objects, including the attributes and the property. Then it is very easy to write the class definition, then create objects. It is also called instantiating objects from the class definition, and then display whether properly objects are instantiated or not. Okay. So this was one homework or exercise which I had left in previous lectures. So I have discussed that. Another was I said that these kind of methods are very important. Important in the sense that from the data science point of view, they are not much used unless you design a complex object-oriented project. But if you want to become a full-fledged Python developer who can develop a complex web application or complex cybersecurity application, Python is a general purpose language, so you can develop a program for any application. So at that time, this kind of methods with double underscore in the beginning and double underscore in the end, they are very useful. They are called dunder method, okay, and they are also called magic method. So the init method is a special method in Python classes. It is also called, no, this is about init method, but that we have already discussed, that it is a constructor and all that. So that we have discussed. Let me make this raw cell. Okay, fine. Here, the method with double underscore or dunder method or magic method have special functionality. Now this is important, this sentence. They allow objects to implement the built-in behavior for standard operator, object representation, attribute, class, access, and more. Now what is the meaning of this sentence? Try to understand. If you remember, I told why class concept is required. Actually, by designing class, we are trying to make a user-defined data type. Because I said that you can write x is equal to 5, and Python doesn't mind. It automatically detects that you are assigning value 5 to an integer variable x. Or you can write name is equal to stages. Then again, Python understands that this is a string created and it is assigned to this string type variable or object variable like that. But the problem is you cannot write car is equal to something like maybe Maruti, then 800cc, like this, then maybe some 20 horsepower. I'm just randomly writing values. Then color is red, and so on things. I cannot write this because Python does not have any built-in car data type. So if I try to instantiate this way, it will throw the error. Okay. So what you have to do is, in this kind of case, is that you have to first define a class car, as we have already done earlier, and I discussed homework also, and then you have to put some attributes and some methods inside. Then that will become a user-defined object. Okay. And that car is called a user-defined data type, just like integer or string or even list, dictionary, stat. These are Python's built-in data types. Similarly, classes are nothing but user-defined data types. Okay, and whenever these user-defined data types are there, we often do not just get satisfied by creating user-defined data types. We also want that these user-defined data types behave as the built-in data type. For example, in built-in data type, say I can use x is equal to 5 and y is equal to 8, and then I can use x plus y. That means I can do addition of those two. And if there are two strings, then we know that it will create concatenation. Indentation error is there, sorry. But 13. So we want that if some two classes are there and they have two attributes, then we should be able to add one attribute of one class with other attribute of other class, or at least object of that class. Okay. So then for that, these kind of dunder methods or magic methods are used. They will implement the built-in behavior. For example, addition, concatenation, standard operations, whatever. Then they will also provide access to the attributes. For example, here only in this example, I have, I think in this example, yes, this homework solution, this get speed, this is called getter method and this is called setter method. So this sets the attributes and this gets the attributes from inside the class. Okay, so this type of functionality also is done by dunder method, that is methods which have two underscores in the beginning and two underscores at the end. Init is just one example. It is a constructor and it initializes the object But there are many other dunder methods like this underscore underscore str and underscore underscore repr and all this. I'm not discussing this, but those who are interested can go through. This is given as a reference here. In the printed note, those who are attending, if you are watching this for my live class or physical class which I am conducting, then in the printed notebook these things will not be there, because in the printed notebook it is designed exclusively in the keeping in mind what is required for data science point of view. But these things are required for becoming a full-fledged Python programmer, Python developer, and that is also one career option. But from data science point of view, this Dunder method, etc., I have used maybe 4 to 5 times in my entire career as a data scientist in maybe around 5, 6 projects, not more than that. The reason is that only unless client insists that you use object-oriented programming, you can achieve the same functionality without object-oriented programming also. So it is easier in that way. Okay. So, data science point of view, you need not worry about this Dunder methods and all that. And those who are completely new to programming, if they are interested in knowledge, they can go through that, refer a few sources here and there. But if you are not interested in becoming an expert programmer, then you can forget about this. Now we will start with this. That is the encapsulation, first part. So what is encapsulation? This diagram tells everything. That there is a capsule, that is the class definition. Inside which this orange color, they are the attributes, and this green color, they are the methods. So this class is a special user-defined data type in which we embed the state of the class also. That is not class, but the state of the object which will be created by that class, and even behavior of the object also. Both, that is attribute as well as method, both are encapsulated in a single capsule. That single capsule is called class. So this phenomena is itself called encapsulation. Now this is fine, but let us see this example by code. So suppose this is a class account, say bank account is there. This is first standard method, that is constructor. So whenever I want to instantiate one account, say account of person A, a new person has come to the bank and he asks that I want to open an account. So we will call this account class, and at that time we will pass owner name A or B or whatever, and we will pass some balance. Even if you don't pass balance, by default we have provided a default value 0, because when a account opens, then it obviously initially it will have 0 balance. And then you set the two object attributes. So this is owner, self.owner is equal to whosoever owner you have passed, say Raj or Bobby or Julie or whosoever, and self.balance equals to balance. So whatever balance you have passed. But here this is important, this thing. We have not written just a self.balance, but self.__balance. Such methods in Python, they are called private attributes. And such methods are somewhat protected. I will not say they are as private as they are in Java or C++, but they are somewhat protected from being accessed from outside. Okay. Similarly, this is another method, deposit. It takes one argument, amount. Self is always there, that we now know. This is the functionality. If amount is greater than 0, then we will increase this previous attribute self.balance by amount. So if amount is say 0, that is balance is 0 initially, and I deposit 500 rupees. So deposit method with 500 rupees, then the balance would become 0 plus 500. Then I again deposit 800 rupees, then the balance would become 500 plus 800. So 1300, like that. So this is how bank works, that you all know, that you go on depositing money, then your bank balance will go on increasing. Reverse functionality is again withdraw. Again you have to pass the amount only, how much you want to withdraw. Self is always there. And if amount 0 is less than amount is less than balance, that is if you want to, by mistake you put some amount which is more than your bank balance. So amount is less than balance, then it is fine. But if amount is more than balance, else part will be triggered, and you will just get a message that insufficient fund. Okay. And if amount is less than balance, then an amount is positive, because 0 is less than amount. So you cannot withdraw minus 5 rupees. You can withdraw positive amount, but it should be less than the balance. Then this part will be triggered, and your balance will be reduced by that much amount. For example, 1300 was the balance. Now if I pass the 200 here, then self.balance would become 1300 minus 200. This minus equals operator we have already seen in earlier lecture, that self.balance is equal to self.balance minus amount. That is what this minus equal operator means. Okay. So what I am saying is, it means like this, that self.__balance is equal to self.__balance minus amount. But this is the succinct way of writing that same thing, minus equals amount. Okay, fine. Then withdrawal will be successful. Now there is one problem with this. Though I have named this as a private variable, this variable is not strictly private in the sense it is for maybe a Java or C++. It can still be accessed from outside provided someone knows this naming convention. This is called name mangling. This attaching to underscore underscore. So if someone is knowing about the naming convention, then this is name mangling, and someone it is just used for preventing accidental access. But it can be accessed from outside if you know the mangled name. So for example, this is the same class, but I have added one method get underscore balance self return self dot underscore underscore balance. Now this is one method by which I can access this private variable. That does not violate the object orientation, because even in Java or even in C++, you can always access a private variable by using a getter method. So that is fine. This is a getter method, but that method must be defined inside the class. It cannot be defined outside the class. If you define this function outside the class, then you cannot access any private variable in Java or C++. But in Python, there is other way. If you don't want to use this getter method, then you can use dot operator, and that is the name of the object, and then dot and underscore underscore balance. That will give you the value stored in this. Let us first create an account. So account is to create the account, you have to pass two things: name of the owner and some balance. So I'm creating account Alice with $100 approaches, and first I have to define the class, and then Alice with $100 approaches. So now Alice account is created, okay, and it has a balance of $100. Now print the balance accessed directly. Can you access the balance directly? Directly, when I say, that means without using this getter method. Okay, so yes, it is possible. I can write object name, because this is object. Remember, this is small a. Class name was capital A. Okay, so this is an object. The object name dot the name of the variable. So object name dot class name underscore class name. This is a single underscore. Remember, and then underscore underscore balance, which is the name of this private variable. Okay, this variable. So even though it is private, you will be able to you will see that I can print its value by just using dot operator. How? Object name dot underscore class name double underscore the name of the private variable. Let us see if I can access. Yes, Alice had deposited 100 rupees, and I can access his or her balance by this method. Now this is what makes Python that debate that Python is not strictly object-oriented language, just like maybe C or C++ or Java. The reason is this: because in C++ and Java, only this method can get you the private variable. So that means you have to provide these getter functions. Okay, so that is another way, but that is nothing special. This is, you can do this with C++ also, you can do this with Java also, and you can do this with Python also. If you provide a getter method, you can always access inner variable, private variable. But getter method must be defined within the class definition. But without any getter method also, if you want to access this class private variable, then you can in Python by this convention. That is object name dot underscore class name underscore underscore private variable name. So please remember this, that why Python is not strictly object oriented language. Okay. Next lecture we will start with inheritance. Thank you.